All right, it looks like we're ready to go. So as we were just mentioning prior to the beginning of class, the course evaluations are now available. This is an important aspect of getting feedback to important parts of this course. So in order to promote that, I'll try to promote it two ways. Number one, this is one way that professors here do improve their courses. So getting feedback from the students. There's a lot of decisions that go into making a course, a lot of material that could be put in, a lot of material that is left out of the course. So it really helps us to know things that you experienced that did work. So for example, the practice time that we had, the MyStat lab, immediate kind of feedback. If you find that stuff helpful, it's helpful to let us know so we can keep that in the course. Things that you find not so helpful, also let us know so that we can remove those from the course and just continually tweak this program that we have so that it can benefit future students. So that's the appeal to your sense of civic duty, but also to reward you yourself for doing the course evaluations. I do award 1% towards your final grade for completing a course evaluation. So I will open up a assignments tab in Canvas where you can upload your confirmation of your course evaluation, and you'll receive 1% towards your final grade for giving us that useful feedback to help us improve this course. All right, so that was a little bit of business. We also have one more little piece of business, which is the final exam that is coming up. So the first thing to mention about the final exam is that it is a final exam in name only. It's really just exam 4. So it's not cumulative, although as you've noticed, statistics is cumulative. So, but you won't be specifically taught or tested on anything from the previous 3 exams. This will be just on the material that we covered since exam 3. So clearly you have to remember everything we've done in this course to understand what's going on right now, but it will again just be on confidence intervals and on ANOVAs. So the date is going to be Thursday, December 19th, so that's the Thursday of exam week, and as I mentioned, it's going to cover confidence intervals and it's going to cover chapter 10 on ANOVAs. Once again, like the previous 3, it's going to be a computational exam. So it will be done again through Excel. It'll be available in Canvas. You'll have the yellow answer cells. There will be 7-ish questions. I'm still finalizing it. Half of it will be on confidence intervals. Half of it will be on ANOVAs. And once again, it will be open book, which means open everything except other people. So whatever resources you want to prepare ahead of time, whatever notes, step-by-step guides, you'll have access to your textbook, you'll have access to your homework, you'll have access to my lab, you'll have access to anything except other people. It needs to be your own work. So that's the final exam. And then today we are going to finish with the content of this course. So today is the last hypothesis test that you're going to learn. And that leaves us next class to have our review session, so our pre-exam review session. So we do not meet on Tuesday. Tuesday is again exam week. We don't have our exam scheduled on that day. We have it on Thursday. So 2 days from now, Thursday, December 12th, will be our review session. And once again, this is an open review session. It's completely student driven. So come with your questions, things that you want to see, things about confidence intervals, things about hypothesis testing with the ANOVAs. It'll be up to you to determine what we cover on that day to help you get prepared for the exam. And as usual, it's optional, so if you feel that you would be better served preparing in another manner, by all means, do that instead. All right, so any questions about the exam or the review session that's coming up? All right. So back to bird brains, back to comparative psychology. So we set this example of animal psychology up last time. So animal psychology, the study of animal behavior. One question that was asked, one bizarre animal behavior is migration. So birds migrate during the winter and then once again come back during the spring. So why is it that some birds migrate vast, vast distances, whereas other birds are quite content to stay here in the snow? And researchers hypothesize that it might have to do with their intelligence, specifically their brain size. So it could be that birds that have bigger brains, birds that are more intelligent, have the resources, have the strategies, and have the skills to survive here during the winter months, so they don't have to take that treacherous, life-threatening journey and migrate to warmer climates. So if you're a highly intelligent bird, maybe that's why you have the behavior of staying put, whereas if you're a less intelligent bird like the Arctic tern, maybe that's why you opt for the behavior, or you've evolved to do the behavior of actually migrating. So that was the question that researchers asked, and today we're going to take a look at the hypothesis test that they used to analyze that, which in this case was the ANOVA. So we're going to take a look at how to do the independent means ANOVA in SPSS, your final hypothesis test, and then we'll just have a quick word about the homework assignment and the Chapter 10 post-test. There are some weird dates coming up because we do have that final exam coming up. So make sure that you have those on your radar, and then we'll have some time for extra practice on this final hypothesis test. All right, so the independent means ANOVA. So this is the question that the animal psychologist posed. So it goes, I'll read it out. One possible explanation for why some birds migrate and others maintain year-round residency in a single location is intelligence. Specifically, birds with small brains relative to their body size are simply not smart enough to find food during the winter and must migrate to warmer climates where food is easily available. Birds with bigger brains, on the other hand, are more creative and can find food even when the weather turns harsh. Following our hypothetical data similar to those actual research results, the numbers represent relative brain size for the individual birds in each sample. And we're going to use an ANOVA with an alpha of 0.05 to determine whether there are any significant differences, mean differences, among the three groups of birds. So the reason why we're using an ANOVA is right there in that last sentence, three groups of birds. So we have one independent variable, which is brain size. We have one dependent variable, which is where the, we have one independent variable, which is migration distance. And we have three levels of that independent variable of migration distance. We specifically have birds that are non-migrating, so one group of birds whose brain size was measured were the birds that do not migrate. The second group of birds were birds that migrate a short distance, and then the third group of birds were the birds that migrate a long distance. So if we only had non-migrating birds and short distance migrating birds, if those were the only two groups that we had, we would do a t-test and we wouldn't need the ANOVA. But they wanted to see if there was any difference between non-migrating, short distance migrating, and long distance migrating. And as soon as we ended up with three different conditions, three levels of that variable, then we were required to do the appropriate test, which is the ANOVA. Excuse me. So here's the data right here. So this is a measure of relative brain size, so the brain size compared to the size of the body. And we won't delve into too much of the details, but basically the higher the number, the larger the brain compared to the body. So it's a way of scaling relative brain size. And as we can see in this first group here, we have 6 birds, and here are their relative brain sizes. We have a mean of 15 for the non-migrating birds. For the short distance migrating birds, once again, we have 6 different birds, and they have their relative brain sizes, and we have a mean of 9. And then for the long distance migrating birds, we have another 6 different birds. There's their relative brain sizes and their mean distance as well. So that's the raw data that we have to work with. And now it is time to do our ANOVA. So with this hypothesis test, we want to know, is there a significant difference between the relative brain sizes of these 3 populations of birds? So once again, we need to go through our 5 steps. Even though it's a new hypothesis test, even though we're now doing ANOVAs, it's still the same 5 steps. That's the basic procedure for any hypothesis test. So let's start it off now with step number 1. So step number 1, restate the question as a research hypothesis and a null hypothesis about the population. So we want to know, do birds that migrate short distances have bigger brains? And we need to restate that as a research and a null hypothesis. So we're going to start off with the null hypothesis first. And the null hypothesis in this case is that all 3 populations are equal. The null hypothesis is that the brain sizes are not different for birds that migrate different distances. And we write that out as the mean brain size for the non-migrating population equals the mean brain size for the short distance migration population equals the mean brain size for the long distance migration population. So this is a way of stating that the mean brain size for all 3 populations of birds is the same. So that's the null hypothesis, and the null hypothesis is very easily formulated or expressed mathematically, right? It's that each population mean equals every other population mean. On the other hand, the research hypothesis has to be the complete opposite of the null hypothesis. It has to cover every other possibility. So if the null hypothesis is that all brain sizes are the same, the research hypothesis has to cover every other possibility, which is not that all of them are different, it's that at least one of them is different. So the null hypothesis is that they're all the same. The research hypothesis covers every other possibility, and every other possibility can be phrased as at least one brain size is different for birds that migrate different distances. And this statement here, we keep it as an English sentence, because to write this out mathematically would be very, very complicated, because you would have to write out the mean of non-migrating birds does not equal the mean of short distance migrating birds, and or the mean of non-migrating birds does not equal the mean of long distance migrating birds, and or the mean of short distance migrating birds does not equal the mean of long distance migrating birds. That's a lot to write, and that's the minimum amount, because 3 conditions is the minimum amount for an ANOVA. So to keep it simple, we just write out at least one brain size is different for birds that migrate different distances. All right, so far so good on the null and the research hypothesis. All right, next we have to determine the characteristics of the comparison distribution. We have a new comparison distribution. We now have an F distribution. So we say goodbye to the T distribution. We say hello to the F distribution. And luckily, SPSS will calculate your characteristics of your comparison distribution. Step 2, we want to set a cutoff probability. So this kind of stays the same. This idea stays the same. Your cutoff probability is still equal to your alpha level. It is your probability line in the sand against which you're going to compare your sample probability. So this is your cutoff probability. We're going to find out what our sample probability is. But your cutoff probability, like a t-test, is alpha. And for this question, the alpha was set to 0.05. Step 4, determine your sample's probability on the comparison distribution. This is, once again, much like a t-test, your p-value. And very luckily for us, SPSS will do this as well. So I will show you where to find the p-value in the output. I'll also show you where to find your F statistic. You'll use that in some of your homework assignments. But importantly, SPSS will do those for you as well. So we are ready now to do steps 2 through 4, get that information. So the data that we're going to be using, you can find it in week 16, class 1, practice chapter 10. That's in your Excel files in Canvas. And as per usual, there are screen grabs in your notes of everything that we are doing here. But we will be doing it live, so if you haven't already, this would be a good time to open up your SPSS, and let's get that all running and ready to go. All right. So we have our SPSS data editor up and ready to go. We also have our data right here. So I'm going to zoom in on that just to get that a little bit bigger. So once again, this is an independent means ANOVA. That indicates that each sample is measured once, and each sample is separate from the other 3 samples. So these 6 birds here in the non-migrating condition are different than these 6 birds here in the short distance migrating condition are different than this group here in the long distance migrating condition. So the other thing that we always need is you need the raw scores. If you're going to use SPSS, you need to have the raw scores. So we are going to set this up. And in the beginning, it sets up much like an independent means t-test. So it still follows that same rule of every single subject gets 1 and only 1 row. So we can start by taking our non-migrating birds, brain sizes, and we can copy that, go to SPSS, we can paste that into column number 1 here, and then let's call that variable brain. And then what we can do, and this is just going to be for illustration purposes, and you'll see what I mean in just a moment. Let's label these ones as non-mig. That is going to be the group to which they belong. These are the non-migrating birds, so we are going to call them non-mig, and let's call this variable migrate. All right, so we got the variable brain that has the relative brain sizes, and we got the variable migrate that shows the fact that they're non-migrating birds. These are the non-migrating bird brain sizes. All right, so we got the non-migrating birds. Next ones here are the short distance migrating birds. So we'll copy those. Once again, we remember that every single subject gets its own row. That means that this data goes into the first column as well on a new row. And we are going to label this as short. So they are part of the short distance migration group. So we'll label those as short, and that will give us the indication that that's where they came from. Now, if we were doing an independent means t-test, this is where we would end it. This is where we would start going to the file drop-down menus. This is where we would choose the independent samples t-test. But this is a new one. This is an ANOVA. So what we need to do here now is we need to enter that third group, which is the long-distance migrating birds. And we pop those up again into their own rows. So they go into column number 1 in a new set of rows. And then we can call these ones long, just to jog our human brains that those are the long distance migrating birds. All right, so far so good? Does anybody not have that data formatted in SPSS yet? All right, so the next thing that we're going to do, and we're going to see why this is in just a moment. We are going to get a third column here, and we are just going to put numbers into this third column, and we're going to number the groups. So we're going to call the non-migrating group, we're going to assign them a number of 1. They are group number 1. Group number 1 is non-migrating birds. Group number 2 is the short distance migrating birds, and group number 3 is the long distance migrating birds. And we're going to go to variable view, and we're just going to put that in as group. And we're going to use this setup to run our ANOVA. All right, so once we have this set up, we got one column of brain scores. We have one column that names the groups, and then we have one column that numbers the groups for our ANOVA here. Once we're done that, we go to Analyze, and we go back to Compare Means. So we're going back to where we've been this entire time. We're going back to the dialog drop-down file menu that has all of the hypothesis tests that we've been using. And we go to, once again, it's being very friendly, SPSS. We go down here to Way ANOVA. So we're doing an independent means ANOVA. They call it a one-way ANOVA. Either way, that's where we're going for this particular ANOVA. So we click on that, and then we get this dialog box here. All right, so does everybody have their dialog box open? Okay, what is the one variable that has not shown up in your dialog box? Migrate. So we did this, we set it up this way to illustrate this very point. For reasons that I cannot understand, and for reasons that make no sense to me whatsoever, SPSS will allow you to label your t-test groups with names. It will not allow you to label your ANOVA groups with names, right? So you'll notice that the way that we set it up, if we set it up analogous to our independent means t-test, then the first column has all of your scores, the second column has the names of your groups. And then there would be this part in the dialog box here where we would tell SPSS what the names of our groups are. It, for some reason, doesn't work in ANOVAs. In ANOVAs, you need numbers for your groups. So I wanted to show it this way because we've been practicing independent means t-tests for so long that you're sort of practiced to do it wrong in the ANOVA way, right? You're sort of practiced to name it, and sometimes students get confused when their data is missing here, when their variables are missing. So don't be confused. Make a note when you're doing an ANOVA. I highly recommend put the group names in there because your brain is probably going to forget what it was that you assigned, which numbers you assigned to each group. But you need to have numbers for your group. So group number 1, whatever it is, call it number 1. Number 2, call it number 2. Number 3, call it number 3. Yep?
Is it always going to be an independent text for ANOVAs?
Yes. So ANOVAs come in many, many different types, way more types than t-tests do. But this is your introduction to statistics. So we're starting it off with basically the simplest of the ANOVAs. And then in grad school, if you continue on to grad school in psychology, you'll find out about the other ANOVAs. Yep. Also, incidentally, it might come a bit sooner than that. So for those of you that are planning to do your advanced lab, you may design an experiment that requires an ANOVA, but not a independent means ANOVA. If that's the case, feel free to drop by my office and just kind of ask what's the test that you need to do, because it is beyond the scope of this course. If we had 3 more weeks, we would cover the rest of the ANOVAs, but it's what it is, the semester that we have. So anyways, we have this one-way ANOVA. Everything needs to be numbers. Raw scores need to be numbers. Group names need to be numbers. So we have that here. The dependent list is your raw scores, your brain sizes, and then the group goes into factor down here. So factor is where you name your factors. We have one factor with 3 levels, so what our factor is goes into this factor dialog window here. The dependent list, that's your raw scores, that goes into the dependent list down here. And then the last thing that we're going to do is second last thing we're going to do, we're going to go to options here. So once we have this all set up, you want to go to options and you want to click here on descriptives. And descriptives is that going to generate that table that gives you the mean of each group, gives you the number of scores in each group. Basically, that table that automatically generated for your t-tests, you have to request it for your ANOVA. So the first thing we're going to do is we go to options and we click here on descriptives. Do not click on anything else. For one reason, we're not going to use it. For another reason, you're going to see that the output for an ANOVA can get a little bit complicated. The last thing you want to do is generate tables that you're not going to use, because instead of having 2 pages to look at, you're going to have 15 pages to look at, and it just complicates matters. So try when you're doing your statistics test to only ask for things that you're going to use. We're going to use descriptive, so we click on that, we hit continue. The other thing that we're going to do is we're going to go here to post hoc. So when you go to post hoc, we'll explain why we go to post hoc later on. But what we're going to do right now is, you know what, we're not going to actually do it yet. We're not going to do it yet. We're going to save post hoc for just a little bit. Let's get the ANOVA done first. So we got brain size in the dependent list. We got group and factors. We hit our options. We're asking for descriptive. We are all ready to go. We hit OK. And boom, we have our ANOVA calculated. All right, did anybody not have their ANOVA calculated? Cool. All right. So now we're going to analyze. Where do we find our information? Where do we find everything that we need to know? So once again, we have our output there. I'm going to zoom in on that output. And once more, we are looking for all 5 steps. So we did the first step. We had the we had the research and the null hypothesis. We need step 2, which is the characteristics. Step 3 is your cutoff probability. And we already know that equals alpha. Step 4, we want our F statistic. But more importantly for us, we want our p-value. And then step 5, we determine whether to accept or reject the null hypothesis. So let's take a look at our output first. So first thing, when we asked for the descriptives in the options, this is the table that we asked for. And that's a very important table because, again, we're setting up a whole bunch of data, and we want to make sure that we entered in our data correctly. So we check our descriptives. And lo and behold, SPSS will let us know for group number 1, we have 6 subjects. For group number 2, we got 6 subjects. And for group number 3, we have 6 subjects. This is a good time to mention, you're going to want to have the labels of your groups handy somewhere. Because doing mental gymnastics like this is hard enough without having it not written somewhere. So 1 equals non-migrating. 2 equals short distance. And then 3 equals long distance. So just have that written somewhere so that it'll jog your brain so you can unload that from your cognitive load. All right, so we have the right numbers in each of those groups. We have the right means, so we can check these means against the ones in Excel and just realize that they are the exact same means. So once again, it just gives us that confidence that we didn't make an error, that we didn't have a slip of the finger, that everything is entered in correctly, so that when we go to interpret the ANOVA, we know that we have the confidence that we've interpreting the right thing. All right, so now we're going down to the ANOVA, this ANOVA table right here. And the first thing we need is we need the characteristics of the comparison distribution. And you'll notice in the ANOVA that we have 3 rows. We got a between groups row, we got a within groups row, and then we have a total row. And that refers to the between groups variance, within groups variance, and then total variance. So they call it different things in different places. You'll see between groups, you'll see between subjects, you'll see within subjects, you'll see within groups. The important thing is the between, and the important thing is the within. They're both the same things. As long as you see between, you're dealing with the between variance. As long as you see within, you're dealing with the within variance. So don't let that other groups or subjects or samples designation throw you. It all means the same thing. All right, so the first thing we need is we need the degrees of freedom. For the comparison distribution, you need your degrees of freedom within, and you need degrees of freedom between. Those are the 2 degrees of freedom that you need. And those are very nicely given to you right there. So we have our between groups degrees of freedom, and that is 2 degrees of freedom. And we have our within groups degrees of freedom, and that is 15 degrees of freedom. And you'll see that the within plus the between will always equal your total degrees of freedom. So these two numbers determine the F distribution. So just like your T statistic was determined by, your T distribution was determined by 1 degree of freedom, this is determined by 2 factors, or 2 degrees of freedom here. But this is your comparison distribution information. 15 within degrees of freedom, 2 between degrees of freedom. Step 3 is our cutoff probability. That is our alpha level right there. So we don't have to look that up anywhere here, and good thing for us because it's not anywhere there. So then the next thing that we need, so we have our degrees of freedom within treatments, degrees of freedom between treatments. Again, within treatments, between treatments, within groups, between groups, within samples, between samples, it's all the same. It's the within or the between. That's the important label there. There's just different ways of calling the same thing. All right, so step 5, we need one last piece of information so that we can do step 5. But step 5, very nicely, same logic as before. So the same slide as we had this entire time. If your p-value is less than your alpha level, we accept the research hypothesis and we reject the null hypothesis. And if your p-value is greater than your alpha level, you accept the null hypothesis and you reject the research hypothesis. So we need a p-value to compare our alpha level to. We need a statistic for the probability of getting those 3 samples. We need a statistic for the probability of getting 3 samples that different from each other, that weird, that unlike each other. That's what this probability is, much like the probabilities for the t-test. So where do we find that information? Well, the first place that we find the information is here. This is your F statistic, and your F statistic is like your samples T statistic. So this is our samples' F statistic. This is the test statistic. If your homework will ask you for an F statistic, that's the test statistic there. And the degrees of freedom that you report are your between and your within. So when you're reporting these degrees of freedom, you mention the characteristics of your comparison distribution, and it'll go between degrees and then within degrees in that order. So that is your F statistic. If you had a cutoff score that you were comparing your F statistic to, that's the number you would compare to your cutoff score. So much like the T statistic, there's a table of F values where you can look up cutoff scores, but we don't want to have to resort to that. We would rather do it all in SPSS and look up our p-value and compare it to our alpha level compared to that 0.05. So what we do here is we need to find that p-value, and that p-value, very nicely, this is actually rather friendly, is right there. It's the one called significance. And notice that you don't see two-tailed on this. That is because it is not two-tailed, and it's always going to be one-tailed. That's the way that an F statistic works. And because of that, we can just read it straight off. So the nice thing about it in ANOVA is that in every situation, you just read that significance straight off of the output. So in this case, the p-value is 0.000. There's probably a bunch more zeros and then a 1 in there somewhere. But SPSS can't even show you that value because it is so low. But importantly for us, that's the p-value as reported by SPSS. All right, does everybody have that information down? All right, so the last thing we need to do now is we need to do step 5. If our p-value is less than our alpha, that's our p-value, that's our alpha. Yes, our p-value is less than our alpha. We're going to accept the research hypothesis and we're going to reject the null hypothesis. So in this case, we decide we're going to accept the research hypothesis. If, on the other hand, our p-value was greater than our alpha value, then we would do the opposite. We would accept the null hypothesis and we would reject the research hypothesis. As it is, p-value is 0, alpha is 0.05. Our p-value is less than our alpha, so we reject the null hypothesis. So we can conclude that at least one brain size is different for birds that migrate different distances. So we can conclude that all brain sizes are not equal, and at least one brain size is different from the other birds. All right, so is everybody at that point? Okay, so at this point, let me ask, everyone here, can anybody see a unsatisfactory element to this end of the hypothesis test? All right, let me give you another example here. Let's say that we ran an ANOVA. Let's say that we worked for a drug company, and we're doing drug trials. And we have 3 conditions, right? We have a placebo condition, that's condition number 1. We have another condition, that's drug A. And then we have a third condition, that's drug B. So, this company spends millions of dollars doing drug trials, they do drug development, they're finally ready for human testing, they go do the human testing, they have an independent means ANOVA, they ask you to analyze this independent means ANOVA, they want to know, the null hypothesis is that all of these effects are equal, right? The effects of the placebo, drug A, and drug B are all equal. The research hypothesis is that at least one of them is more effective. One of them is more effective than the others. So you come back to your employer and they ask you, did you run the statistics? And you say, yes, I run that independent means ANOVA, and guess what? We have rejected the null hypothesis. Hooray, we accept the research hypothesis. At least one of these is more effective than the others. What's your next question? What's your boss going to ask you? Which one? And at this point, our reply would be, I don't know. That's highly unsatisfactory. Could you imagine being in that situation when they're like, great, is it drug A, is it drug B? And you're like, I don't know. It's one of them, but I don't know which one. We can't have that. Same thing here. We know that at least one brain size is different from the other brain sizes, but we don't know which one. We don't know if non-migrating is a bigger brain. We don't know if the difference is between short and long, non-migration and short, non-migration and long. We know one of them at least is different. Could be all 3, could just be 2, could just be 1, but we don't have any information yet in terms of who's different from who. So in that case, we have to go a little bit further. We need to ask which brain sizes are different from the others. We need to know, is it that non-migrating is different from short distance migrating, and or is it that non-migrating is different from long distance migrating birds, and or is it that short distance is different from long distance migrating birds? So for that, we got to go back to SPSS, and we're going to do a post hoc analysis. So we go back to SPSS. We're already all set up, we're already all good to go, so we don't have to do much more. But what we're going to have to do is we're going to have to ask SPSS to actually run that analysis. So we go back to SPSS, we can close down, all right, and we'll close down the output here. So we already have the data set up correctly. We go to Analyze, Compare Means, Way ANOVA. We already have it all in there. It's all ready to go. It's all good to go. What we're going to do now is we're going to go to this button here that says Post Hoc. And Post Hoc literally means after the fact. So this is an analysis you do after the fact that you found a significant difference. This is analysis that you can do to show you where the differences lie. So you do this after you reject the null hypothesis. So you accept the research hypothesis, now you're wondering where's the difference. So you go to your post hoc, i.e. after analysis tab here. So we click on this, and what we find is that there are a number of different post hoc tests. And these ones is again something that you'll learn beyond the scope of this course. They all have different pros, they all have different cons. The ones that are the most used are going to be the Bonferroni, the SIDAC test, and the Tukey honestly significant difference test. So the Tukey is also known as the Tukey honestly significant difference test. When you read about research that uses ANOVAs, these are the ones that you're typically going to see the most often. What you don't want to do is what we just did. You don't want to click on a whole bunch of them, right? You definitely don't want to click on all of them because, again, you're going to have an 18-page output. What you want to do is you want to use the one that is being asked for in the question. So at this stage in your statistics development, you will be told, use the Bonferroni post hoc analysis. Use the Tukey honestly significant difference post hoc analysis. And that's just the Tukey one that's right up there. Use SIDAC post hoc analysis. So read which post hoc analysis you're supposed to do. Once you're in grad school, you'll learn all about the differences between them and you can make your own decision. But for right now, for this question, we're going to use Tukey just to illustrate that. So the first thing you want to do is you click on the post hoc test that you want to do. The second thing you want to do, and this will allow you to use SPSS to double check your interpretation, go down here to this significance level and change it to your alpha level. So our alpha level is 0.05, so it's already by default set up for that value. However, if it was 0.01, we would change it to that significance level. But in this case, it's 0.05, so we're going to leave it at that significance level. So we've chosen Tukey. We've chosen a significance level of 0.05. We now hit continue. We're now ready to go. We can hit OK. And you'll notice that the exact same analysis has been done, except now we have this extra 2 tables down here. All right, so the table that we're going to work with is this multiple comparisons table right here. So it's the post hoc test, multiple comparisons table, but now we have that extra information, and this table will allow us to determine which groups are different from which other groups. All right, so before we leave that, does everybody have that table? It generated? Awesome. All right, so let's go to the interpretation of that table. So this table, it can be a little bit tricky the first time you see it. And that's just because it's not really designed for the way that the human brain works. So I'll just point that out and hopefully, we'll learn how to deal with that. So we know that there's a difference somewhere among these groups. So now we want to know, where does this difference lie? So what we're going to do is we're going to take a look at this table, and in this first column here, that's what lists which 2 groups are being compared. So this first row here is going to compare group 1, non-migrating, with group 2, short distance migrating. And this table is also one of the reasons you want this written down somewhere, because the table is hard enough to interpret without you devoting cognitive resources to trying to remember what was group 1. Was group 1 non-migrating, or did I put group 1 long distance migrating, because long distance migrators are the first winners of the migration race. I don't know. You don't want to do that to yourself. Write it down somewhere. So this is non-migrating versus short distance migrating. So this one lists the groups that you're comparing. This column here, that lists the mean difference between the samples. So it literally takes the sample mean of group, in this case group 1, and subtracts from it the sample mean of group 2. What we're really interested in, though, is this significance column right here. So you can think of this table as a group of t-tests. It's analogous to a group of t-tests. They're not actually t-tests because they're controlled to not expand the alpha level, the experiment-wise error rate. That's a kind of technical analysis, but you can think of them as being individual t-tests where you compare group 1 to group 2. You compare group 2 to group 1, and this over here is like p-values for those t-tests. So those significance values, that's what we're going to be looking for. That's where the important information in this table resides. So far, so good? All right, so let's take a look at it piece by piece. So we want to compare non-migrating birds to short distance migrating birds. Remember that the question wanted us to ask, is the difference that we found due to a difference between non-migrating and short distance migrating birds? First thing you need to do is you need to find that information on your table. So we look for group 1 compared to group 2, and we got that right there. There's group 1 compared to group 2. And then all we do is we scroll across and we look at that significance level. And we compare it to alpha. And we go through the same decision. If that significance, that's your p-value for this test. If that p-value is less than alpha, then we reject the null hypothesis and we say that there's a difference between the two groups. If that p-value is greater than alpha, we accept the null hypothesis and we say that there is no difference between the two groups. So we say that yes, there is a significant difference because this significance level is less than our alpha, this p-value is less than our alpha. And also, as a double check, SPSS has marked this comparison with a little asterisk right there. So in your mean difference column, there's a little asterisk. So we decided that that this difference is significant, that we're going to reject the null hypothesis for this comparison. And SPSS has put a little asterisk there, and it says, yep, the mean difference is significant at the 0.05 level. So this only works if you enter in the right level in the options section for your post hoc analysis. So remember how we had that significance level and we made sure that we updated it and it was 0.05? That's the level SPSS will compare your table to. So make sure that that level is your alpha level for your question. But more importantly, we have now determined that yes, indeed, non-migrating birds have bigger brains than short distance migrating birds. So one of the differences is this one right here. Non-migrating birds are different, not equal to short distance migrating birds. What about non-migrating birds and long distance migrating birds? Now we're comparing group 1 to group 3. So we go back to our table and we need to find group 1 compared to group 3. And this is where I don't know what the designers were thinking here, but there is group 1 compared to group 3. And what they thought was that it was, I guess, more elegant or more easy to understand if you just understood that the 1 here carries down until the line, rather than just printing a 1 there. I don't know why. But you also have the redundant comparison of 3 to 1. So not only are there numbers missing here that you need to fill in on your own using your own human brain, but this table is about twice as big as it really needs to be. Because you'll notice that it compares group 1 to group 2, and it also compares group 2 to group 1. Well, guess what? It's the same answer both times. So anyways, however your mind works, find group 1 compared to group 3. That's the column right there. Once again, we scroll over to the significance value. That's your p-value for that comparison. That value is less than our alpha level, less than 0.05. So this is going to be significantly different. We reject the null hypothesis that there's no difference between non-migrating and long-distance migrating birds. And also notice, there's that asterisk again. SPSS double checks it and says, yep, the mean difference is significant at the 0.05 level. So it looks like non-migrating birds also have different brain sizes than long-distance migrating birds. So we have one more comparison to do, short-distance migrating birds versus long-distance migrating birds. So we have group 2 versus group 3. We go back to our table. We need to find group 2 versus group 3. We have it in that row right there. So remember that this 2 carries down into the empty space. So we got group 2 versus group 3. We scroll across, and now we have a significance level of 0.138. 138 is greater than 0.05. So now we accept the null hypothesis. We say that there is no difference in brain sizes between short distance and long distance migrating birds. And lo and behold, there's no asterisk there, right? SPSS has not flagged that as a significant difference. So it turns out that the final story is that short distance migrating birds and long distance migrating birds, they have the same intelligence. They have the same brain sizes. The only difference is for non-migrating birds. They have bigger brains than short distance, and they have bigger brains than long distance migrating birds. And that is the final analysis. That's a satisfactory conclusion. We now know the entire story, so now we have the complete hypothesis test picture. All right, any questions about anything we've encountered today? All right, so that wraps up your final piece of statistics that you will be learning this semester. So just a note, your homework assignment is going to be due December 11th by midnight, so that's the typical time. It's due midnight before the next class. Next class is going to be a review session, so let me know if there's anything that you want to cover or come with those questions. Chapter 10, post-test, that's going to be due Monday, December 16th at 11:59 p.m. And that is going to allow you to finish up your post-test, get everything squared away, so you have a few days to prepare for this final exam. And then your MyStatLab study plan, we only have the one study plan, the one pretest, for this part of the course. So just so that you're aware, that is due midnight before the day of the exam. So if you want to earn 100% on your pretest by completing the mastery points in the study plan, please make sure that you do that before Wednesday, December 18th at 11:59 p.m. That is the deadline for that. Mm-hmm.
Is that only for if you did the mastery points? Sorry.
Yeah, so that is if you did your pretest and you want to complete the mastery points so you can increase your score on the pretest, those mastery points need to be completed by December 18th. Yeah, the pretest has already been completed. All right, so we got about 20 minutes left in class today, so there are some more in-class practice available. So the Excel sheet has the data for this. It is an ANOVA test, independent means ANOVA, on different keyboard designs. And once again, it asks you to find if there are significant differences between the errors. And then for your post hoc analysis, this is what you would be looking for. Which keyboards are significantly better than the other keyboards? Use the two key honestly significant difference post hoc test. So you will be told which post hoc test you need to do. And then there's your output that you're going to be looking for. There's the all the steps, including your interpretation of the post hoc analysis. So I kind of blew through that so that you can try to do it without seeing the answers, but you know where to go in case you do. Other than that, we got 20 minutes. I'm going to turn that over to practice time at this point. If you want to call in an early date, feel free. But if you have any questions, feel free to call me over.